So, ladies and gentlemen, you are all welcome to my YouTube channel. So, today we are going to look at a question that says, what is the quantity of aluminium is what quantity of aluminium is deposited when a current of 10 ampere is passed through a solution of an aluminium salt for 1930 seconds. So, one very interesting thing that we should understand, this question is coming from electrolysis, and the element that is used during this electrolysis is aluminium salt. So we are to calculate the quantity of an electricity. Therefore, we know that in electrolysis, we have a formula. Remember that according to the first law of electrolysis, that's the first Faraday's law of electrolysis, which states that the mass of an element discharged during electrolysis is directly proportional to the quantity of electricity that passes through it. So, of course, the quantity of the electricity that passes through it is usually represented with, of course, capital letter Q. So, this Q is always equal to IT. The Q is equal to IT, while the I stand for current, the T stand for time. So therefore, from the question, we have our I. So our I is given, the I is given as 10 ampere. So the I is 10 ampere. And of course, the T is already given in second, which is exactly 1930 seconds. So therefore, to get our Q, we are going to use the formula that says Q equals to IT. So therefore, now we have our so therefore we have I as 10, and then we have our T as 1930. So therefore now we have 10 here. We have 10 times 1930. So therefore, if we now take this times this, we have 19300. And of course, the SI unit for the quantity of electricity is coulomb. So we have the quantity of electricity here as coulomb. Have the quantity of electricity here as coulomb. So therefore, we have our I now. So since we have our I, we can simply get so our I is already given here as, so sorry, we have our Q. Our Q here is calculated as 19, we have 19300 column. So you have 19300 column. So now, of course, we know that it's an aluminium. So when aluminium undergo electrolysis, it usually has 3 charges. It has 3 charges. So the electrons of aluminium is 3 plus. Remember, aluminium is a metal with 3 electrons on its outermost shell, indicating that the aluminium can lose 1 electrons. So during electrolysis, of course, this is the addition of electrons. During reduction, that is at the cathodes, we have neutral aluminium. Of course, since we have 3 electrons here, it means that we have 3 Faraday. And we know that 1 Faraday is 96500. Since here is 3 Faraday, so we now have 3 times 96500 column. So we're now going to fly this. So if we now have, so we now have 3 times 96500. We have 96500, which will give us, of course, 289. So we have 289, have 289500, 289500 column. So of course, we know that the mass of aluminum is 27. So since here we have the mass of aluminum here is 27. So we can just simply say that 27 gram of aluminum is present in 289,500 column. And of course here we have X gram, which is unknown, is present in 19, is present in 19300 column. So we now cross multiply. So after we now cross multiply, what are we going to get? After we cross multiply, we are now going to have 27. We're now going to have 27. Now going to have 27. Now going to have 27 times 19300, which is equal to X times 289500. So we're now going to say divide both sides by 289,500, and also here divided by 289,500. So this one will now cancel this, and at the end we now have, of course, we are now going to have 27 times 19300 divided by 289,500. So let's see what we are going to have. So after we freeze our calculator, and at the end we are going to have our X is equal to 1.8 gram. So the answer is 1.5 gram, which corresponds to option B. So this is the answer for option B, and this is how to get the mass of an element during electrolysis. So it means that during this electrolysis, the mass of the element that is deposited is 1.8 grams. So in 10 ampere, when a 10 ampere of electric current is applied in aluminum salt, it is going to give us an aluminum ion, which is 3 plus, and of course about 1.8 gram of mass will be deposited. And of course that is why we are able to get 1.8 gram. So this is how to calculate this in electrolysis. And I think, ladies and gentlemen, you need to understand also the concept of an electrolysis, which is very important. So what is electrolysis in just a simple way? So electrolysis, of course, is a chemical decomposition of compounds into their component ion by passing an electric current either in a solution or in a molten form. So it means that when you apply an electric current here is I. So when you apply an electric current, so according to electrolysis, is the chemical decomposition of compound into their component ion by passing an electric current. So this is the chemical compound. So usually ionic compound or covalent compound during electrolysis, when electric current is applied, they usually break down to generate sodium ion or ions, of course. So the ions here generated, we have sodium ion and chloride ion. So the sodium ions are called the sodium ions because they have positive charge, so they are called cations. While the negative charge are called anions. And of course, remember, during this electrolysis, we have what you call electrolytic cell. And in this electrolytic cell, we have two electrodes, And these two electrodes comprise of cathode. We have cathode and anode. So we have cathode and anode. So which one is cathode and which one is anode? So cathodes are the negative electrode, cathode, and then anodes, they are the positive electrons. So this one, they are called cations because they move toward cathodes during electrolysis, and anions are called anions because they move or they migrate toward anodes during electrolysis. And of course, why are they called cathode? Because cathode, they have sufficient electrons, while sodium, they have here, because we have sodium ions, so it means that the sodium ions have insufficient electrons. So for it to become neutral, it needs to go to the cathode and gain electrons and gain electrons. So it must go there and accept electrons for it to become neutral. While the anions, it must go there and of course, because they have sufficient electrons, the negative charge here in the chlorine, it means that they have sufficient electrons, while anode have deficient electrons. So therefore, the anions will go to the anodes and deposit electrons. So they lose electrons. So that is why, ladies and gentlemen, usually oxidation is taking place in the anode, while reduction is taking place at the cathode. So reduction is taking place at the cathode. That is why usually oxidation is taking place. Oxidation is taking place at the anode. Oxidation is taking place at the anode. Why? Because the anions will go there, which is the negative charge, will go there and lose their electrons. And of course, when you said oxidation, it means the loss of electrons. And we have anions. So when anions actually move toward the anode, so they gain electrons. So that is why the gaining of an electrons is called reduction. So reduction takes place at the cathodes. And then, of course, in this electrolysis, we have electrolyte, that is the compound that undergo the electrolysis. So usually when this electrolysis is actually taking place, so either in a solution or a molten form, the electrolyte will decompose to produce ions, but the ions usually move in a random direction until when electric current is applied. That is when the anions will start migrating, whether the direction of cathode or anode, depending on the nature of the ions. So then let's look at another question. So the next question here is, we have another question. So the oxidation state of calcium is, so we want to now get the oxidation state of calcium in calcium chloride. So how do we do that? We want to get the oxidation of calcium in calcium chloride. So of course, we know that chlorine have atomic number 17. So therefore, in the first shell, we have 2 electrons. Second shell, we have 8 electrons. And the last one is 7. So it means that it needs only 1 electrons to become octet or to become completely filled. So as a result of that, it cannot actually give out all its 7 electrons. So it is going to accept 1 electron. So that is why their oxidation number is -1, because they are going to get 1 electrons for them to become octet. So the oxidation number of chlorine is -1. So how are we going to get the oxidation number of calcium? So you see that the compound we have here is calcium chloride, So we don't know the oxidation number of calcium. So we can actually leave it as X. So we can leave it as X. So let's say our Y here is X. And of course, we know the oxidation number of chlorine here is -1. So we are now going to say X, because we have only 1 calcium. So we are going to say 1. We are going to now say 1 times X, then plus the oxidation number of chlorine is -1. So we are going to say -1, and we have 2 chlorine. So we are going to say -1 times 2. Then of course, because the net charge here is 0, so because there is no positive charge and negative charge here. So it is going to be 0. It is going to be 0. So 1 times x is x. Then we have minus 1 times 2. We have minus 2. So then it equals to 0. So we now have x is equal to, when this minus 2 is transferred to the other side, is going to be plus 2. So therefore now the oxidation number of calcium, the oxidation number of course the calcium, the question is going to be minus 2. So let's look at the answer very closely and see. So we have plus 2. We have plus 2. So therefore now, based on that, it means that our answer is here, is option B. Our answer is option B. And then the next one is actually the next question is, the mass number of an atom of an element is the sum of course, remember in the atomic structure, when the structure of the atom, we have something like this. So in the atoms, we have nucleus. And in the shell, we have electrons. So this circle is called shell. And there is an electron, which is negative charge. And in the nucleus of the atoms, we have proton. And neutron. We have proton and neutron. So the protons is positive charge and this one is neutral. So what is the atomic number of the mass number of an element? So the mass number of an element, is equal to proton plus neutron. So when we add proton and neutrons, then it is going to give us the mass number of the element. So the answer is option C, protons and neutrons. Then the next question is the existence of 2 or more forms of the same element in the same physical state is said to be then allotropy. The answer is allotropy. Then which of the following are the radioactive isotopes used? So which of the following is an application of radioactive isotope? So it is actually A, scientific research, dating techniques, and of course the treatment of cancer. So yeah, of course, in scientific research, we use radioactive isotopes. Like for example, if you want to know maybe the location of a particular material or substances, you can use it actually. You can use radioactive substances to trace the position or the location of a particular disease. That is what we call radioactive tracer. So it's a research. Then dating with radioactive element, you will be able to know the date of a particular material, like rocks. You can know the age of a rocks using radioactive substances. So there is dating techniques and also treatment of cancer, like X-ray and gamma rays. You can use X-ray in the diagnosis of the disease, of course, but for the treatment, when you have gamma ray, you can use it for the treatment of cancer. So it means that all of the above is the answer here. So all of the above is the answer to this question. Okay, so ladies and gentlemen, if this is the first time you are coming to my YouTube channel, please subscribe. Thank you.